Hello everyone, it's Quick Flash, and today I'm making a video going over the history of EmuFlight, what EmuFlight is, what's currently happening in EmuFlight, the future of EmuFlight, and everything that makes EmuFlight interesting and unique. So to start our discussion today, I would like to talk about our good old friend Butterflight. Butterflight is the project from which EmuFlight is forked from. If you don't know what that means, it simply means that EmuFlight shares all the same code as Butterflight. Essentially, we just took all the Butterflight code and made our own additions to it. Now, if you haven't heard of what Butterflight is, that's probably because you haven't been flying quadcopters very long, or you've just been keeping out of social media. And you know, that's entirely fine if you've never heard of Butterflight, but I'd just like to run down a brief history of Butterflight because that's honestly a fair bit of the history of EmuFlight, is some of that Butterflight history. So, Butterflight was created because of some controversy with filtering. As we can see, RS2K, the developer that created Raceflight, he created a fast Kalman filter for Betaflight. And you know, he created this filter, and as we can see here, it was eventually actually added into Betaflight. Now, that filter caused a lot of controversy, and it was eventually taken from Betaflight. They removed the feature, and because of all that whole debacle, some people decided that they needed to create their own fork of Betaflight in order to, keep that filter alive. That's how much they believed in it. And so that's why Butterflight was created, simply because of that Kalman filter and them wanting to keep it in the code. Now, around the same time as Butterflight, but not completely coincidental to Butterflight, this company called Helio came out. And Helio, one of the co-owners of Helio was RS2K, the developer that created the Kalman filter that ended up creating Butterflight. He took that same Kalman filtering idea and took it to another level by creating a flight controller that not only had one STM32 chip, but two, an F4 and an F3 chip. One chip dedicated to filtering, one for the rest of the flight code. He created a company, Helio, and because of the controversies of the past, Betaflight was not very fond of Helio, and so Helio rather chose to support and work with Butterflight. And Helio and Butterflight became good friends and did a lot together, and they were such good friends that many people mistakenly believed that Helio was Butterflight or Butterflight was Helio and vice versa. Even though they were technically two separate entities, they were really working so close together that it was hard to really understand what was happening. Now, what did Butterflight accomplish? Here we can see Butterflight version 3.6 in the bottom right, and then this other post that says Betaflight BEF, Betaflight 3.5.6 merge. Now, Butterflight 3.6, as you can read there, 3.6 is rebased with Betaflight 3.5.1. So, in Butterflight version 3.6, they rebased their code around Betaflight 3.5, but retained a few features from Butterflight. Those features were fast Kalman filter, buttered PIDS. The fast Kalman filter obviously being what created Butterflight. The buttered PIDS is just a slightly simpler PID controller, just had less things you could play with. Butterflight IMUF, so basically the code to allow Helio flight controllers to work in Butterflight, a 9-point TPA curve, that's the TPA that Raceflight did, and then just some minor other things. Then if we look at Betaflight 3.5.6, it's essentially just merging in the last changes that Betaflight made in 3.5.6. Nothing too much was added. And that release was the last release that Butterflight had. Butterflight came out, said they were going to change the world, added that Kalman filter. We're getting tons of people excited, getting tons of people to use Butterflight, and in the end, they were beta flight with a handful of changes, some different defaults, and other minor things. But at the end of the day, they still remained popular, mainly due to Helio and how popular Helio was. However, due to legal troubles and other issues that plagued Helio, and just, the Helio developers deciding to end the project, Helio died. Along with Butterflight, they both died, and people that had Helio spring flight controllers were honestly left in the dark. They didn't know if they'd ever be able to update their flight controllers again or what was going to happen. And that's kind of where EmuFlight comes along, because when Helio went out of business, they decided to release the filtering code that went on that F3 chip. Before then, the code had been closed source, and after this point, they decided to open source that code and make it public in the hopes that someone or some team of developers would come out and continue to develop on the project that they had initially started. And that's exactly what happened. It didn't happen immediately. It took quite a few months, but eventually a man by the name of Marinas, he's not the one that posted these Facebook posts, but Marinas, he started to make updates to the filters for Helio flight controllers. And he made updates to the Helio IMUF. And as we can see, Andre, an EmuFlight pilot, but Andre, a great guy, he was the first guy to test the new filtering that Marinas was coming out with. And Marinas made some quite good improvements to the filtering for Helio flight controllers. Made some good changes, made it better than it was before. And honestly, it's kind of impressive, He didn't have huge groups of people. He mainly just had Andre testing it and flying it and seeing if it was any better. And eventually, the very wonderful thing happened that Marinas decided to take some of the filtering ideas from the Helio IMUF and to implement that into Butterflight. And so that's where I came along. Once I had seen that Marinas had forked Butterflight and taken some of that code that Helio had added for their flight controllers and put some of that code into normal flight controllers, I was intrigued. Before then I thought it was just a little project that was going to die simply because Helio hardware was dead, and eventually there wouldn't be any more flight controllers that could use that filtering. And so that's where I came along. I decided I wanted to help out Marinas and keep this project alive, as I loved his version of Butterflight that included the Kalman filtering and the IMUF filtering. So I came along and decided to help. I originally started by making this repository on GitHub. I called it Butterflight Universal IMUF because it was the first bit of code that allowed any flight controller to have access to some of what the IMUF did back in the day. And to be honest, it was, nothing much different than Butterflight, just Butterflight with a handful of changes to get it this way. And I created a release, put that public, and shared it with a handful of people. I think it ended up getting a couple hundred downloads. And then after this had happened, the group of people that had flown this, we were primarily discussing things in the Helio Discord. And we moved over to a new Discord, and we're discussing things and decided that this project was special and that it needed a name. And so we decided to allow users to input all the different name ideas that they had, and then we would vote on them. At the end of the day, it came down to two names, EmuFlight and Phoenix Unleashed. I suggested the name Phoenix Unleashed. It didn't win, and I'm quite happy with the name EmuFlight. And that's the name that ended up winning. We let our small user base decide the name, and that's what they decided. And the really cool thing was, after we decided it, everyone was excited. We were moving forward. It was really exciting. It was really fun. And, within a day, we had gotten that iconic EmuFlight logo. One of the guys that was in that group does art like that. And, it was really cool to see community coming together and just people so excited, and that logo pop up almost instantly, and we all gravitated towards it, decided to pick that to be our logo. And we haven't looked back since then. Since that time, we had EmuFlight release 0.1.0. And as you can see, Andre used to just be a tester, but now he's actually started helping develop EmuFlight. We had version 1, which was kind of a disappointing release, if I'm going to be honest. As I was developing things, I accidentally removed the Helio IMUF filter from normal flight controllers. I removed it as a default, and then I inadvertently made it no longer work without realizing it. And, we did have some other things in the code, like that decay, Emuboost, that new TPA. But aside from that, it was essentially just Butterflight with a few changes. After that, we did have release version 2. We released it as a release candidate, simply because our thought process was that right now, everything we're developing in EmuFlight is not yet a full version. It's all a test version, and that'll be the case until we get version 1.0.0 out. So we just decided to release this as a release candidate. Version 3 won't be released as a release candidate, but it's kind of under the same premise as this version in version 1. Anyhow, in version 2, we, for the most part, fixed the Kalman filtering for regular flight controllers. There was still small part of it that didn't get completely fixed, but there was a working Kalman filter in EmuFlight version 2, as well as we added presets into the configurator. Now you can just hop on the configurator, pick a preset. It's honestly a really cool idea. We did have some updates to the Helio IMUF controller. We got the not fast enough racer mode, cinematic yaw, and an update to feathered PIDS, which used to be buttered PIDS back in Butterflight, as well as a few other things. Now, this brings us to where we are today. And now I'd like to just go over the new features that have been added, what's coming in version 3. Going forward, I'll only be discussing code that will be in version 3, because some of the things that we've released, we've already removed from the code as, we tested it, decided that we, in the end, didn't really like it. And a few things have actually been removed from the code. I won't get a ton into that because there's nothing very substantial that's been removed, mainly things that no one was using already. The only notable exception being that feed forward in EmuFlight version 3 will be gone. We have removed feed forward. Now, let's dive into this with one of the first features ever added to EmuFlight, which was Emuboost. And as you can see here, we have our P-term, effect, and our error. So this graph is basically showing, this bar up here is how much effect the P-term is having, and this is the error. And for those of you that don't know, P-term is calculated by taking your P-term value and multiplying it by your error. So if you have a P-term of 10, it's 10 times your error, and that's the P-term effect. There is a multiplier added to it to shrink it a lot more, but that's essentially what it does. And so here, if you just had normal P, it would be like this black line, just linear, just follows up there. If you have some Emuboost enabled, you actually get this non-linear kind of exponential curve that will increase your P-term as the error increases. But then wherever the Emuboost limit is set to, the P-term will stop at that point and continue along that line. So that brownish line, so your P-term will follow that brownish line and then go to the yellow line if you're using Emuboost. And now the reason why we added an Emuboost limit was simply because if you don't have that, as you can see, this is exponential, it'll start spiking up towards infinity as the error gets really big, and it just causes big problems as your P-term gets ludicrously high. And this can kind of limit that. Now, as for tuning Emuboost goes, what I've found is that quadcopters that are less powerful, like whoops, stuff that's slightly overpropped or other things, that this Emuboost can actually work really, really well for prop wash handling and other things. You know, when I personally tune the Emuboost, you can tune it to both, you know, your stick feel or your prop wash handling and whatnot. If you want to tune it for stick feel, you just increase these numbers until you get it about where you like it. I'll generally use it just to tune out my prop wash. And I'll generally just get P to about a fairly normal number. And then I'll just increase my Emuboost limit quite high, you know, 150 or something. And then just slowly increase my Emuboost. Because if the Emuboost is really small, then that curve is going to be really shallow. It's not going to increase very quickly. And I'll slowly increase my Emuboost, and I can actually see that help fight prop wash. Because when you enter prop wash, your quad's jerking in directions that you don't want it to go, and by having this P-term boost non-linearly, kind of exponentially, as it jerks in a way you don't want it to, it can very quickly compensate for that, quicker than just a normal P-term could. And so that ends up working quite well. And like I said, weaker quads like whoops or other things can really benefit from it. I've been able to see whoops, you know, remove yaw washout just by tuning Emuboost and Emuboost limit. So that's something to think about with that. Next up here we've got feathered PIDS. This is unique to EmuFlight. The term came from Butterflight's buttered PIDS. And essentially all that this is like it says up here, it's just Dterm on measurement. Now what that means is your Dterm can be calculated in two different ways. One of them is Dterm from measurement, which calculates your Dterm based on your gyro, or Dterm based on error, which calculates it based on the error that your quadcopter sees. Now without getting into way too many details, Dterm from measurement will be smoother, and Dterm from error will feel more sharp or aggressive. Because whenever you move your sticks, Dterm based on measurement will completely fight your movements, and Dterm from error will push into those movements. And inside of here, if you set feathered PIDS to 0, you will be doing Dterm from error, and if you want your PIDS more feathery and smooth, set it to 100, you'll have Dterm from measurement. Now you can go anywhere in between there, and if you want to mess with this, which I recommend, you know, anyone that's flying, just change these values, see how it feels. You'll definitely feel the change very quickly. But you'll want to take these feathered PID values, and as you change the feathered PID values, you may find that your Dterm needs to be tuned slightly differently. Perhaps your filters need to be tweaked a little bit, or perhaps your Dterm values need to be increased or decreased. On some craft that I've flown, I find that Dterm from error is just a lot cleaner. The Dterm sounds cleaner, well, the quad sounds cleaner with Dterm from error, and I can run higher Dterm and it flies better. Other quads, I found that measurement just works better. It just depends on different things, but usually, just personally, I prefer Dterm from error. I prefer the way it feels. For me, it usually flies better, but Dterm from measurement is the way Betaflight calculates Dterm, and it's how I'm fairly sure Flight 1 calculates it. The way KISS calculates Dterm is Dterm from error, though. So if you want to copy a KISS feel a little more, maybe do Dterm from error. Other stuff, use Dterm from measurement. And, you know, the default value for this isn't 0, it's 100. And that's basically your feathered PIDS. If you want more information about that, I know that Mark Spatz, UAV Tech, has made a video about Dterm from error versus Dterm from measurement. And that'll be, you know, something interesting to see if you have an interest in that. Up next we have eye decay. For those of you that don't know what eye decay is a way of handling eye term accumulation. So we can see from these graphs here that the blue line is your eye term, the yellow line is the error, and basically what your eye term does is it sees error and slowly grows over time. So we can see how the error is up here and how your eye term is just growing and growing and growing, and as soon as it crosses this line, you can see that the D term starts to shrink. Now what eye decay does is it shrinks the D term faster than normal. So in this example you can see here that as this increases, as the error gets down here, D term shrinks quicker and quicker. Now if you look here, your error is about the same here, but it grows far slower than it decayed. That's because eye decay increases how quickly the eye term decays. Now, the main use for this can be handling, eye term related bounce back at the end of flips or other maneuvers. It can also just allow you to run a higher eye term if you run more eye decay. You can run into some problems with eye decay though. If you have your eye decay too high, then your eye term will quickly shrink quicker than you might want it to and can cause some other weird issues. Normally the most that people seem to like it is about 6 or 7. 6 or 7, all the way down to like 3 or 4, maybe even 2. It kind of just depends. So that is eye decay, just a way of shrinking your eye term quicker. Now a value of 1 does nothing. Your eye term shrinks at a normal rate. A value of 2 shrinks your eye term twice as fast. So you can see that running a value of 10 might get a bit ridiculous, as it takes 10 times as long for your eye term to grow as it does to shrink. So something to keep in mind. Next on the list, I've got some of the whoop and angle mode code that is in EmuFlight. When I say whoop, it's not code that has to be used on a whoop, but it is more primarily used for whoops or cine whoops, things of that fashion. The first one is cinematic yaw. What this does is it combines your FPV camera angle degrees, if you know what that is, and changes that a little. So what FPV camera angle does is if you set this to say 15, if your camera is set to 15 degrees on your quad, and you set the FPV camera angle to 15 degrees, if you do a yaw movement, instead of doing that weird kind of movement that yaw normally does, it'll just look like you're flying at 0 degrees of tilt. Your camera won't change the way it's looking. It'll mix some roll input to your yaw when you run FPV camera. Now when you turn on cinematic yaw, in order to get cinematic yaw to work, you need to set in a value for FPV camera angle. And then you need to turn on cinematic yaw. And what cinematic yaw will do is as you pitch forward more and more, it will keep compensating your yaw with roll and your roll with yaw as you pitch more and more, essentially making yaw always yaw around whatever ground is. So whatever is straight below you, so the earth, it'll yaw around that, which means that if you were using this and you pitched forward, say to 45 degrees, and you gave a yaw, it would compensate with the same amount of yaw as it does roll. And you would, it would do that coordinated turn for you. Now what the FPV camera degrees does when you have cinematic yaw turned on is it sets the maximum compensation angle that cinematic yaw works at. So for example, if you set it to 10, anytime you're tilted past 10 degrees, it just acts like you have set FPV camera angle static to 10. If you set it to 90, which is the max, it'll go to 90 degrees and it'll stop, because anything above 90 in the math for it gets all weird, as you're now starting to go upside down, and it just maxes out there. And so that's something that some whoop guys really like using. If you know Project Mockingbird, he's a big fan of it, and that works really well. And here we have the angle, horizon, or NFE mode. Now, I'm first going to just cover the NFE racer mode. For those of you that don't know, NFE racer mode is angle mode, but it's only angle mode on roll. So only your roll is corrected, your pitch angle is acro. So it's angle on roll, acro on pitch. And I personally like that for racing whoops around the house, doing other things. I find it just a lot more fun. But that's something to play with. And obviously NFE racer mode only works while you're in angle mode. Because when you're in acro mode, you're just acro. But here, I've taken the PID controller and added some of the same math that Silverware, which is well known for flying very well in angle mode. I've added a lot of that angle math and stuck it in EmuFlight. Now you might wonder, before your angle mode code just had, essentially two values, your angle strength and your angle limit. Granted, now there are more values, but it does fly better. So what we have here is we have a proportional, or P, an angle P, and an angle D, an angle derivative. And we have a high and a low. Now essentially, what the point of this is, and these values don't reflect values you'd actually want to use so much, but you have PIDS for high angle air and low angle air. And a common problem with whoops in angle mode is you'll crash into something and you'll vacuum up against a wall or something else. And one of the ways that you can combat that is proportional. You can think of it as angle strength. The math is calculated the exact same way. And so low angle strength, or low angle air, P, if you set the low angle P and the high angle P to the same value, it'll just act like the angle strength from before. It'll act exactly the same, but what the difference here is as your angle has more of an error, so it means you push your stick to move your quad to face 45 degrees, but it's only at 35 degrees, how hard should it push to reach that angle? That's essentially what the P is doing. And so you want the P for low to be fairly high, and the high error to be fairly low, so that when you do crash into something and your angle error pops up really high, the quad just doesn't jerk to react to it and end up sucking you against a wall. And now that you're sucked against a wall, you have a high error, which pushes the quad really hard and keeps it sucked to a wall. Instead, you can make the angle error for very high, you can make the high angle error the high angle P, or proportional, quite low, so that when you do crash into things, it just kind of bounces off of it. You can set that low angle error higher to get a more locked in feel, or however you'd like that. Then you also have a derivative, or a Dterm, that will act as, the same as a normal Dterm, or at least Dterm based on measurement, and, it'll slow down your P. You've probably seen some whoops before where if you just bang the stick in angle, it'll kind of bounce around a little bit. The Dterm can help with that. It can smooth it out a little bit. And generally, your Dterm high for angle, you want that to be fairly low, and your Dterm low doesn't need to be super high. But it does help your angle to fly better. It does help clean out some of the noise from your accelerometer, as the accelerometer is quite noisy. As it fights against the P. I know it sounds odd that it can help clean up some of the noise, but just the way that it works, it actually can. Then we do have an angle feed forward, and this feed forward is the only feed forward still in EmuFlight, and it's just a feed forward for the angle mode. And all it does is it applies a temporary increase to the angle that you want to be set to, which just acts as a little feed forward boost. Seems to work pretty well. You know, you increase that, things will feel sharper in angle mode. And if you increase it too high, you'll see your whoop overshoot whatever angle you've set it to. So you don't want to run it too high, but you can increase it to change the feel a little. And then lastly, we have angle expo, which just adds an exponential curve to your angle. So basically before, it was just when you'd move your stick, whatever your maximum angle mode was set to, you know, your angle, you know, max angle, you know, a lot of people are on 45 or something, so the most they can tilt their whoop in angle mode is 45 degrees. You set the angle expo to some value, and instead of your stick just linearly reaching that 45 degrees, it will now have an exponential curve, kind of like normal rates, how they have expo. But it adds just a bit of expo to that. You know, if you want a softer center for your angle, add some expo, and that way you can still have a really, you know, high end angle of, you know, 80 or 75, and still have a fairly soft center angle. And moving forward from that, we have TPA and SPA. Now TPA is throttle PID attenuation, and SPA is stick PID attenuation, or stick position attenuation. You can call it really what you want. But what your TPA does is our TPA works different than Betaflight's TPA, different than anybody else's TPA. And, you know, we did that because we're cool. No, actually, this is one of the first things I coded. I just essentially split TPA into TPA-P, TPA-I, and TPA-D. And I changed the math of it. The math in Betaflight basically says if you set this value to, say, 0.9 like we have here, that at full throttle, you will only have, you know, it'll chop 90% of your PIDs at full throttle. However, in EmuFlight, this means that at full throttle you will have 90% P, 130% I-term, and 75% of your D at full throttle. Then TPA breakpoint works like normal as well. When your throttle goes above that value, it starts to apply this shrink, or growth in the case of TPA-I. And normally, you know, if people have bobbles on any axis, just increase your TPA-I. Because honestly, with how your quad flies, your quad can use a lot more I-term when you're on the throttle than it can without. You know, if your throttle is at 0, you can't handle near as much I-term as you can when your throttle's near full. Or as your throttle's at 50 or 60%, you can just handle more I-term. You know, if you want to test that out for yourself, just go out and fly. Put your I-term to a high enough level that you get I-term bounce back after quick flips. Do that at 0 throttle, and then start doing flips at half throttle or 75% throttle. And you'll see that you get far less bounce back at higher throttle. And that's just because your craft can handle more I-term when you've got more throttle. And, you know, you get a bit more locked in. And a lot of people that might have problems where their pitch will bobble when you give it a full throttle punch, increasing TPA-I, that can help remove that. You know, for the most part, you don't need to use anti-gravity to remove that. You can just increase your TPA-I. So that's something. And you can also, for your TPA-P and TPA-D, you can increase these past 100. I've occasionally done that. I don't really do that so often. It's just usually the I-term, but that option is open to you. With stick position attenuation, you have your roll, pitch, yaw, then you have PI and D. Now basically this is whenever you move any of your sticks past the center, it will essentially, imagine that you've got TPA, which is based on your throttle, and now you have SPA, which changes your PIDs based on your stick position. So as you start moving your sticks farther from the center, it starts applying these PID changes. Now what I've found is that your I-term, when you have your stick moved all the way, can start to become a problem as it accumulates and grows and starts giving you issues. However, with this, you can take that I term and shrink it, or you can increase your P term, get a bit sharper of a feel, do some things. I mainly use SPA for yaw. I just enjoy the way that I can set my SPA P quite a bit higher for yaw, and then decrease my I. Well, not have it decrease my I. And when I've done this, I've found that I can boost my P term to 150, 160% for my yaw. Increase my I term on yaw to say 150. Just run something ridiculous for I term on yaw, and just run enough SPA I that it just shrinks the I term as I move my throttle out. As I move my yaw stick, that I can do. So I can have a really, really tight locked in yaw, and I can just move that stick, and I don't have any bounce back. It's super sharp. It gives a really nice P term. I prefer this most for P term. It's still there for pitch and roll. Mainly the D term is what's used here. A little bit of I, mainly D, for people that want to kind of, people that might have some overshoot at the end of flips. You look at a log, and as you go out to full stick, you see some overshoot. You might want to increase your SPA-D to help combat that. And then you've got SPA-P to make things a bit more aggressive and quick as you enter a flip. It's really up to you. It's more of an advanced thing. You really don't need to touch it. These work the same way as TPA, so if you set them all to 100, they do absolutely nothing. Values below 100 shrink, values above grow. Here we have all the filtering. Something you can see is in EmuFlight version 3. We've split up the filters to be roll, pitch, yaw, roll, pitch, yaw, roll, pitch, yaw, roll, pitch, yaw. Now, if that intimidates you, I am genuinely sorry. The reasoning behind splitting it up to roll, pitch, and yaw is before there was a filter that was the yaw low-pass filter. It was an EmuFlight, and when I looked at the code, it actually did absolutely nothing. The yaw low-pass filter did 0. And so I thought, okay, what we can do is split up roll, pitch, and yaw, set up the filters independent of each other, and then if you want to run a lot more filtering on yaw, you can set yaw to like 50 or 30, and you can still get essentially what adding a separate yaw low-pass filter would do. Something else I found was the Dterm low-pass 2 did absolutely nothing. Only Dterm low-pass 1 had any effect. I fixed that. Now Dterm low-pass 2 actually works. That's why these Dterm filtering options are actually the new default. Instead of a Dterm low-pass filter at 65 Hz, we now have 2, because we can actually cascade these filters. These filters, aside from being split per axis, work just the same way. So if you don't want to have to deal with black box logging or tuning per axis, just set all of these values to the same. All your D-term, set them to the same value. All your gyro, set them to the same value, and it'll just be like before. It'll be the same way as Betaflight does it. But if you want to really fine-tune your yaw, or maybe your pitch or roll just has more noise for some reason, you can really get in there and fine-tune it. If you're not logging, then pitch and roll, for the most part, should just be set the same. And yaw is the one you can play with. I've been playing with yaw, and I've been able to find that I can run a yaw low-pass filter way lower than I can run pitch and roll. I can stick that down to like 50 or 60 or even lower, and it still flies great, and it can actually help me remove noise. And just because of how odd yaw works and everything, it actually ends up working out really well. So I'm actually happy with the ability to set my yaw low-pass filters quite low. In here we've got our IMUF filters for regular flight controllers. You have the Q and W, and this new parameter sharpness. Basically, to make this simple, because there's nothing. Well, this is essentially a Kalman filter, a predictive Kalman filter with a dynamic Q. Now, I'll just in layman terms try to explain Q and W. There's nothing too crazy complex about it, But essentially W is how many samples the Kalman filter looks at in order to do this math. So if you set it to 32, the Kalman filter will look at the last 32 gyro samples in order to do the math for the Kalman filter. The Q value is a value that's based off of the Kalman filter's prediction, and it essentially uses all the different basically the W looks at a bunch of values, looks at that many samples, and it comes up with basically a value. And then the Q value takes that and does a little bit of math to it. Essentially, the lower you set Q, the more you filter. The higher you set Q, the less you filter. In EmuFlight, the Q is dynamic, which means that we can raise it and lower it in the middle of flight. The way we do that is with some fancy math that you don't have to worry about, and this IMUF sharpness. Now the sharpness, the higher you increase it, the more dynamic the Q becomes. So what that can mean is you can filter a lot more, but make it more dynamic so that you have a low Q, a lot of sharpness, and it will kind of dynamically be able to increase Q when overfiltering starts to become a problem. And these values, they don't have really any real world correlations. Like you have here your Dterm low pass filters, you've got 100 hertz or whatever. You don't quite have that here. This you have to tune a bit more by feel, or if you look at logs you might see that you need a bit more or less. As far as W goes, if you're flying a larger craft, you usually want to run a higher W. Smaller crafts or more race-like crafts usually want to use less W. You can just honestly play with it, see what works better for you. Just go up and down with it, the default's 32. Try 64. Is that any better? Okay, it's not. Go back to 16. Go up to 32. Go up to whatever. Try 6. Try Q at 100. Try it at 3000 default. Try it at 6,000, 8,000. Try sharpness at 2,000. Just mess with these values, and as you do that, you'll kind of learn the way that it works and how you can tune it. It's nothing too difficult. You just see more noise, or you can kind of hear noise, lower that Q. You hear some prop wash or mid-throttle oscillations, you want to increase Q. Now you can also mess with sharpness. A lot of our testers now are actually just setting W to 16, Q to about 4,000, and just messing with sharpness, and they don't need to touch the rest of it for the most part. With the sharpness, Q and W are not nearly as important. Sharpness can do a lot of what Q and W used to do, just because of the way it works. Here we've got two new filters, Witchcraft and Smart Dterm Smoothing. Witchcraft comes directly from Raceflight. I ported that code over from the version of Raceflight that was made public, that RS2K made public. I've been given permission from I've been given permission from Preston Garrison to use that code, so I have delved into it, looked through it, and added a few things. One of those things is Witchcraft. Witchcraft is a lagged moving average filter for the Dterm. Essentially, what it means is if you set this to 5, it will look at the last 5 Dterm values, because Witchcraft affects your Dterm. It'll look at the last 5 Dterm values and take the average of it. And then it'll spit that out. And that's your new Dterm, is the average of the last 5. And then you get another Dterm sample in, the oldest sample disappears, and the newer sample comes in to replace it. It's quite simple. Mess with this. I generally find a value of 0 to 3 seems to work good. Some people like it around 6. I'm generally down, if you set this to 0 or 1, it does absolutely nothing. I like it usually about 2 or 3. Seems to just help smooth the Dterm just a little bit more. And then here we've got smart Dterm smoothing. This, in a sense, is the way that EmuFlight is able to handle deminimization that Betaflight has, and it's also a way that we can kind of very, in a smart way, control the Dterm and, you know, get rid of some of the noise that it has without really filtering it. Now here's an example of smart Dterm smoothing. Now, this log is a log with a smart Dterm smoothing value of 50. What that means is if you look at a black box log and you see PID pitch equal 50, not 50, equal 5 or higher, this debug will always be 1,000. This debug here is how much the smart Dterm smoothing is shrinking Dterm or not. 1,000 means it's not shrinking Dterm, and below 1,000 means it's shrinking Dterm. Now, it's able to shrink Dterm down to half of what its normal value would be. So you can see here towards the left that this value is stuck at 500. And so down here, as your Dterm is very small, it shrinks the Dterm a lot. As Dterm increases, it starts to allow Dterm to act more like it normally would if it wasn't being shrunk. And so this top value is a multiplier to the Dterm. So if it's 1,000, you know, just divide that value by 1,000, so you'll get 1 up here, down here you'll get 50. So essentially low Dterm values are shrunk, high Dterm values are allowed to act like normal. So the way that would work is if you come in here and you set smart Dterm smoothing to 100, then over here in a log, any value below 100 will be shrunk. And it gets shrunk more and more as the effective Dterm is smaller. And so what that can essentially do is times where you're just cruising, going straight forward, times where excessive Dterm becomes an issue, it will shrink your Dterm and remove a lot of that noise that Dterm has. You know, you can see from this log that I've turned off the smoothing and you don't see any Dterm spikes. Part of the reason is when your craft is being more agile, when Dterm is higher, the gyro will work better. When your quad is rotating quickly, when the gyro is quickly changing, your gyro is actually more accurate. I don't completely understand why, but it's just how it is. So when your Dterm is high, your gyro is actually more accurate. And so that's, you know, when the Dterm's low, that's when the gyro is the least accurate, but that's when smart Dterm smoothing shrinks that value. Something that I've found is that smart Dterm smoothing and witchcraft can kind of go hand in hand, because witchcraft will look at multiple samples of Dterm, and smart Dterm smoothing looks at how close the Dterm is to 0. So I guess the actual way that the smart Dterm smoothing does its math is it looks at your Dterm and then divides it by your smart Dterm smoothing value, and then it just constrains that between, you know, it creates this multiplier between 0.5 and 1. It will either shrink your Dterm down to half of what it is, or it'll keep it the same, or it'll do something in between. And so, you know, in this example, if your Dterm was at, if the Dterm before the smart smoothing was at a value of 2.5%, that's what it's showing in the log, and your smart Dterm smoothing is set to 50, then it'll do 25 divided by 50, that'll give you 0.5, and you'll have this 0.5 multiplier. So any values above that 2.5, those will actually start to be increased, not increased, but they'll be allowed to act more like normal. And as soon as you go past 5%, it would act completely like normal. So that's what a value of 50 would do. A value of 75 does a lot more. The default is 5, which is 0.5% on a log, so it doesn't do a whole lot. But like I said, I've found witchcraft to work well with it, because witchcraft will look at multiple samples. And if your Dterm is right near 0, bouncing up and down, sitting near zero, you're having these little noisy spikes bouncing up and down on the Dterm near zero, that averaging will kind of take those highs and lows and kind of get rid of that a bit, and then the smoothing will just crush it the rest of the way. And you can get rid of non-Dterm effects down low, and once your Dterm starts acting a lot more, it'll go back to normal. Next on the line, we have another filter, which is a fix and improvement to the dynamic notch filter within EmuFlight. So, we've got this famous guy, Powell. I'm not going to try to say his last name, I would butcher it. But we've got Powell, the Inav developer. He was kind enough to port his Inav matrix filter into EmuFlight. And it's essentially just a really good improvement to the dynamic notch filter. At the same time, we fixed a problem with how the notch filters within EmuFlight were calculated, and this has just been a big improvement. I really enjoy this filter. It's great. It really helps with noise and other things. It's a really good addition. Thanks, Powell. Next up here, we've got another really fun feature. It'll be added into the configurator like the other features are at some point. This is vbat throttle compensation. Now what this code does is it attempts to make your throttle consistent. It attempts to give your throttle a consistent feel throughout your battery life. So a good way to put that is, as your battery starts to sag, at the start of the battery, you move the throttle to 50%, you experience X amount of power. At the end of the battery, you stick the throttle at 50%, you don't get the same level of power. However, with this code, it allows your throttle to be boosted, limited, or have both happen to it based on your battery voltage. So essentially you have your vbat comp, the comp short for compensation, your vbat compensation reference, and that 3.7 means that it's 3.7 volts. So if you set the vbat comp type to be both, whenever your battery is above 3.7 volts, it will cut the top of your throttle off and rescale your throttle to give you less power. As your battery starts to die, it'll remove that chop that it did to the top of your throttle, that limit, and give you access to more of the top of your throttle. And so your throttle will keep more of the same feel throughout its flight. As soon as it goes below 3.7 volts, your throttle will be boosted to help it maintain the same feel. What I find is that, bigger craft, I just prefer to use limit. Little whoops, I'll use both. I haven't really found a good use for boost. Then you have the vbat comp throttle level. That just essentially says how strong it's going to limit it or boost it or do both. Different crafts need different levels. 75 seems to work good. The Tiny Hawk, which is what this was tested and developed on, with a value of 75, you can fly, and your hovering throttle will be the same throughout the whole flight. If you set it to both, set it to 75, and you fly a Tiny Hawk, it will be exactly the same. And then this vbat PID compensation changes the vbat PID that was back in the day. It replaces it, uses this math for the vbat PID, and it only adds a compensation to your P term, not your I term or D term. Vbat compensation on only the P term is just a better way to do it. I found that out after some discussions with Not Fast Enough, the silverware developer, and I tested it, tried it, and sure enough, vbat compensation on only the P term works better than on the P, I, and D term altogether, like the old version was. One last command CLI only setting is crash flip power. What this is it's your turtle mode power. So the turtle mode code has been slightly changed. Before, you really weren't getting full power when you tried to do a flip. You were only getting 70% power. So this by default is 70. Before, you were only getting 70% power when you tried to do a turtle mode maneuver. I've now changed it so that you can get full reverse motor power when trying to do turtle mode. But you have to just come in here, set that value to 100 if you want full power. But like I say, before, you were really, because of the math, limited to 70%. That was what you were at. Now you can get that full 100% power when you try to do a turtle. Now, this is really only helpful for whoops, as far as increasing this value. That'll be helpful for whoops like the Tiny Hawk that struggle to do turtle mode. Some whoops that could barely or couldn't do turtle mode can now actually do turtle mode by setting this to 100. For more powerful craft, or some toothpicks or other craft where you're scared that you'll burn out a motor every time you turtle, you can lower this value and make its effect way smaller so that you don't have to worry that, as you do a turtle mode, that you're going to burn out any motors. You can set it down to 25 so that as you try to do a flip in turtle mode, that you're not just going to burn out your motors, that you'll still have power, but it won't be nearly the same. So this is just a new thing you can play with. I think it's kind of cool. And the last new thing in here, but I think it's personally one of the greatest things to make it into EmuFlight version 3, is rate dynamics. Now, rate dynamics is an entirely awesome feature. It takes the whole tuning your PIDS to give you stick feel and throws that out the window. The idea that I had was that you should be able to get really good stick feel without messing with your tune. In my opinion, you should fly your quad. Well, especially now that I've added this, the way that you should tune your quad, if you want to do that, is fly it, do prop wash maneuvers, do hard flips. If you see bounce back, tune out the bounce back. If you see some prop wash, do what it takes to tune out the prop wash. Tune your filters a little bit, get things dialed in. Don't worry about the stick feel. If the stick feels good, if the stick feels bad, don't worry about it yet. Just keep flying. Get rid of your prop wash, get rid of the bounce back, get rid of any bad behaviors your quad might have, like the nose bobbing when you give it throttle or anything else. Get rid of those bad behaviors and then come over here to rate dynamics. This will give you any stick feel you want. I can promise that this can give you the stick feel that you want. Now we've got 3 variables here, and we have 2 of each variable. We have a center and an end. Now, what are these? To quickly explain, center is mid-stick, end is the end of your stick. So whatever value you have for center, that's the value that you have when your stick is, near the center of your stick. This is the value that it'll be at the end of the stick. And of course, it meshes between the two as you move your stick. Sensitivity is essentially how sensitive the quad feels, how quickly it reacts. If you have a quad where you do a flip and it feels dull and it doesn't feel like it's quick enough or kind of feels laggy or whatever, back in the day you would just add some feed forward. And that's what you do to correct it. But instead, now we have rate dynamics. It's a much better way to accomplish it. Everyone that has been testing this absolutely loves it. It gives them the stick feel that they want. It's easy to figure out how you need to change it to give you that stick feel. So basically, sensitivity just increases your rates or decreases it. A value of 100 does nothing. So if I set the value here to 120, it takes my stick value and it multiplies it by whatever number I have here. So 100, it multiplies it by 1. If I have 120, it multiplies my stick position by 120. not 120, 1.2 or 120%, which means that my stick's going to feel more sensitive. Now you might wonder, if I change this, I'm just changing my rates. What's the point of sensitivity? I'm just changing my rates. The point is we then have a correction. So sensitivity will boost your rates temporarily or decrease your rates. Values above 100 boost your rates. Values below 100 decrease your rates. Correction basically creates a term that will grow over time. So essentially correction is an I term. If you want to think of it that way, it actually is an I term. But correction will just take that temporary boost or shrink in your RC command, and it will correct for it. The higher the value, the more it will correct. A value of 10 corrects 10% of your changed rate every time it loops through the code. A value of 100 corrects for all of it. So you can't even put in a value of 100 because it's useless. If sensitivity was 100 and correction was 100, it would do nothing. So instead, your correction can go from 0 to 95. And so the higher you set your correction, the more quickly it will correct for the sensitivity, the temporary boost or decrease in your rate. And your weight, it kind of feels like a weight on your sticks. It prevents change in your rates. What this will do is it will look at your previous rate and it'll look at your new rate. Whatever value you have set weight to, it will block that percentage of the change. So if I was moving my stick and I set this to 50, every time I move my stick, it would block 50% of that change. And so every time my receiver gets another command, it'll block 50% of the change every single time. So this can really be used to smooth out your sticks. If you want to do really smooth freestyle, you can bump up the weight a bit. For super cinematic flying, if you set the rate center weight, you set this value up to be, say 80 or 90, near the center of your stick, you can bang the stick around and you'll barely notice a change. Your sticks will still change, but it won't be aggressive or jarring. And so if you want to fly a cinewhoop or something super cinematic, you'll bump that weight up near the center. And if you make the weight near the end, near 0, you can still do normal speed flips and it won't feel delayed or lagged because it won't be. It'll feel normal, it'll feel great. And then you can come back to the center and this weight will come in and prevent your quad from just having an abrupt stop. It'll slow down your rates. So essentially the rate dynamics just adds a whole nother level to your rates. It takes your rates and allows ways for your rates to be slightly tweaked. It adds some dynamics to them. Your rates will still be the same. If you hold your stick in whatever angle you've got it set to for, a second or two, probably even less than a second, your rate will be back to normal. And it will be just the same rate as normal. However, before then, the way that it reaches that rate that you've set it to by moving your stick won't be like normal. It won't happen instantly. It'll either boost up past it and come back down to it, or go below it and slowly build up to it, whatever the case may be. And that is what is able to change your stick feel. You want a more sensitive, aggressive flying quad, set the sensitivity higher, have a low correction, have a slightly low weight. You might think that the weight sounds bad because it slows things down, but everyone I know that tests this uses the weight value. This comes from racers, from freestyle pilots, from cinematic pilots, long range. All the guys that have been testing it use a bit of each of these. The default values are these, which won't do anything. If sensitivity is 100, correction can't do anything. And if weight is 0, it does nothing. So this is just normal rates. like I say, you want to play with it, you want to go racing, you might want to set the sensitivity up to like 130 at the center, maybe even 150 at the end of your stick, and set up the correction to maybe be 35 or 25, then the weight near 30 for center and 0 near the end of your stick. And that can still give you really abrupt, sharp stick feel without the need of feed forward or anything else to give you that great stick feel. And you know, the feedback I've gotten from some of the EmuFlight test pilots that are really good racers is that the stick just feels better than what feed forward can get it. You know, these guys, they've flown Betaflight 4.2, they've flown Flight 1, they've flown EmuFlight. And the way that this can mess with their sticks, they prefer this setup for affecting stick feel more than any of the other flight softwares that they've flown. This feature here, I think, is really going to be a game changer. You know, regardless of, you know, like Project Mockingbird said, regardless of how well you think you can tune any software, you know, Betaflight, whatever, you can't get the stick feel that EmuFlight has. You know, if you might say, okay, EmuFlight, it doesn't fly as well as Betaflight, it just has more prop wash or it has other problems. You know, you might have that opinion. However, these people that have tried these rate dynamics, they just love this. It's something that works so well that regardless of how well you could tune another firmware, you couldn't easily replicate the stick feel. And that's because this makes our rates dynamic. Our rates aren't static like in Betaflight or Flight 1 or any other software. The rates in EmuFlight with rate dynamics are dynamic. They're kind of changing as you move them rather than just instantly changing like the other softwares. It'll grow and shrink and do all sorts of fun things, and it leads to some awesome ways of messing with your flight. You know, you want to fly racing, you can do this. You want to do freestyle, this will give you the stick feel you want. You want to do super cinematic, this will give you super cinematic. Whatever feel you want, rate dynamics can give it to you. And I really think that so many pilots are going to be converted to rate dynamics. You know, I've had some testers that had half their fleet on Betaflight and half of it on EmuFlight. And since coming out with this, they just haven't enjoyed the way their Betaflight craft felt in the air. It didn't matter how well they flew, it just didn't feel good. And so they've converted them all over to EmuFlight. This is my personal favorite setting that's been added to EmuFlight since its inception. You know, because you can argue everything else in the code that relates to flight. You can argue all of that and say, you know, it actually doesn't work as well as, say, Flight 1 or KISS or Betaflight or whatever. You can try to argue that all you want. But this stick feel code, this rate dynamics, it's good. It's really good. And yeah, I'm excited to see all of you trying it and seeing what you think about it. And then lastly, you know, I just wanted to talk a little bit about what the future of EmuFlight has in store. Because obviously we've been able to see, you know, the history of EmuFlight, how EmuFlight started as just a humble fork of Butterflight, and how it's grown. You know, it received its name, and since it's grown into a software that many pilots know about, whether or not they've flown it. And, you know, the future of EmuFlight, the plan that we currently have, and this, you know, is our game plan, is to release version 3, version 0.3.0, release that version, and then go back to Betaflight. Look at their code, go back to Betaflight 3.5. and start doing what's called cherry picking. Take the code that Betaflight has added since 3.5 and start merging it directly into EmuFlight. Now, I know some of you might be thinking, I like EmuFlight because it's not like Betaflight version 4 or Betaflight 4.2. I like it because it's different. I like Betaflight 3.5, not Betaflight 4. I don't want EmuFlight to become like that, and don't worry, we're in the same boat as you, if that was your thought process. Personally, I do prefer Betaflight 3.5 to the newer Betaflights. Betaflight 4.2 is, I'd say finally like the first version of Betaflight that can hold its own against Betaflight 3.5. So that's just my opinion, but because that's my opinion and the opinion of most of the EmuFlight test pilots as well as the developers, that's our opinion. We want to take the Betaflight code, merge it into EmuFlight. However, when we see code that deals with flight dynamics, we're going to pause, take a step back, and decide whether or not we want it. We'll add it, test it, see if we like it or not, and there's going to be plenty of code that Betaflight 4.2 has added that relates to flight that has been changed since Betaflight 3.5 that we simply won't have in our code. There's going to be quite a bit of it that we're going to throw out the window. Like I say, we've already removed feed forward. All the feed forward changes that Betaflight's been doing, we're never going to see them. EmuFlight doesn't have feed forward. The new rate dynamics has removed the need for feed forward. That's why we removed it. And so because of that, we're just going to we're going to take all of the Betaflight code, commit by commit. So a commit is when some Betaflight developer puts in some code. They say, I want to add this piece of code. They make a commit. Those changes they made get added. We're going to add all the Betaflight changes commit by commit into EmuFlight. And the stuff that deals with flight code, we're going to take a step back, figure out if it does fly better or is better, and then we'll see if we're going to add it. Stuff like the VTX tables won't be implemented as they currently stand. A modified version might be. We're going to have to discuss that when we get to it. But that's the plan. The plan is to release version 3 and then for the large part halt the EmuFlight development. Not completely, because I still have lots of different ideas about how to improve the flight dynamics or performance. I don't want to ramble about them because if some of them don't come to fruition, I don't want to disappoint people or have tons of people asking me about it. But I'll still have some of those ideas. I'll still work on some of them. But for the most part, I'll just be pulling that Betaflight code, getting EmuFlight to be on par with Betaflight as far as targets go, as far as hardware support, as far as all those other improvements that they've made, improvements to the loop time, improvements to everything else. I'll be taking that. We'll be adding that to EmuFlight, and by the time we're done, we're going to call that EmuFlight version 1.0.0. That will be our first full release, our first release candidate, our first non-development code will be version 1, which will essentially bring us up to speed with Betaflight 4.2 as far as we want. All the Betaflight 4 code we want, EmuFlight will have. And, when we do this, we'll be discussing with the community. We'll be discussing with each other as devs. We'll be discussing it with our testers. And we'll be flying it and making sure that these improvements are better. Because at the end of the day, pilots will fly whatever they think flies the best. And that's why there's so many pilots flying Betaflight 3.5 versus the newer Betaflights. Even though the newer Betaflight versions have lots of new code that does things that is really nice or has improvements, things that don't have anything to do with flying, all these other improvements that they've added, people still fly version 3.5 because they prefer it. They think it flies better. they don't fly it because of the non-flight code. They only fly it because of the flight code. And so we don't want to, ruin EmuFlight for the future. We're only, we're going to make sure that EmuFlight flies well. We're going to add the other cool features that's in the newer beta flights, like, what is that called? Crossfire, like Crossfire LQ, or some of those other things, or, just all these other good updates. We'll be taking them, and all of you will be flying a much better version of code by the time we're done. And I am really looking forward to that. But for now, we just need to finish up the last little touches to get version 3 out the window and get it into all of your hands. Yeah, so that's my overview of EmuFlight. That's the history. That's where we currently stand. That's all the features that I could at least think of in EmuFlight. I probably forgot a few. But that is EmuFlight in a nutshell. And if you sat here and watched the whole video, that's incredible. I hope you enjoyed it. I hope you set it on like 2 times speed. Made life more bearable. But yeah, thanks for listening. I hope this gives you a better insight into EmuFlight. I hope this gets you excited about EmuFlight version 3. And I hope this gets you excited about the future of EmuFlight. Because, I really don't want to follow in the shoes of Butterflight. And like you can see, we haven't been following in their shoes. We've been doing our own thing. We've been pushing code. And I think that in the future, EmuFlight will be able to hold its own against Betaflight and be a real competitor to them. Anyhow, thanks for listening. Have a wonderful day.